Welcome everyone. I will be presenting my study titled Greening Strategies for Improving Residential Existing Buildings' Performance in Bahrain's Tropical Desert Climate. Starting with the motivation. The residential sector in Bahrain consumes up to 48% of the national energy production. The majority of this energy consumption consumed by these buildings is mainly for meeting the cooling demand, which can reach up to 80% of the total electricity consumption. Now, the building envelope is the protective shell of these buildings, and therefore retrofitting the building envelope itself could serve as a less obtrusive approach to improving building performance. Now, I will go over the approach for this study, and I will discuss the materials. Here we have the diagram summarizing the approach. Information was collected regarding the building envelope materials, building plans, and weather data for Bahrain. Greening strategies were also reviewed, mainly extensive green roof and modular green wall. Simulation software Design Builder was utilized in order to understand the energy consumption of the existing buildings and then to test the improvements following different configurations for greening strategies. Then the outcomes were compared together to gain an understanding of the improvement in building performance and the potential for reaching net zero energy in the future. Moving on, here we have the different configurations simulated in this study, starting with the baseline, which serves as the benchmark for comparing all the different configurations in terms of building performance. The baseline serves as the existing status of the building, which follows the regulations set by the Electricity and Water Authority in Bahrain. The different configurations include extensive roof treatment only, different facades with the extensive roof treatment, and then we have two facades, south and west facade with the roof treatment, and finally we end with four facades and the roof treatment. Of course, to do this step, a 3D model was created for the residential unit on Design Builder. Different simulations were run for all of these configurations with the greening strategies, and then building data, materials, and occupancy schedules were fed into the program as well to create a realistic outcome for the electricity consumption. Here below, we can see the different layers for the followed strategies, which includes the extensive green roof and the modular green wall. Now we will take a look at the results of the study. Now here we have the diagram for the monthly electricity consumption for different configurations. We have the baseline roof on the south wall with the roof, west wall with the roof, and finally the south and west walls plus the roof. And looking here, we can notice a 29% reduction in building cooling demand by covering the south-west walls plus the roof with modular green wall and extensive green wall. Now, here we can compare the best performing configuration, which is the southwest plus roof with covering all the facades or covering the facades without the roof. Now, obviously, covering all the facades plus roof with green treatment offers most reduction when it comes to cooling energy consumption. Although the difference between covering two facades and four facades is quite incremental with only 1.3%. This means that it would be much cheaper to cover two facades and the roof than covering all facades of the building. Now, in order to test how efficient these solutions are and gauge the building's ability to reach net zero energy, the electricity consumption was compared against on-site energy generation, which was based on another study that tested the ability to generate electricity through solar panels on a unit of a similar size. Now, looking at the solutions, we can notice that the southwest roof solution and the all facade plus roof solution both offer high savings and high reliability on renewable energy alone. So covering the south, west, and roof with green strategies can give the buildings the ability to rely up to 80% of its cooling on generated electricity from solar panels and 82% if you cover all facades, still proving that two facades and the roof could offer the best outcome when it comes to cost and savings. Moving on to conclusions and limitations. The conclusions include that greening strategies could greatly reduce building cooling loads. The south and west facades are the most important facades to cover and offer the best outcomes. Finally, the greening strategies were able to reduce electricity consumption for cooling by a lot, but it wasn't sufficient for reaching net zero energy. However, near zero energy could be reached in the future with proper application of greening strategies. The limitations for the study, including the um, limited focus on the strategies themselves. It focused a lot on greening strategies, but it did not look at reflective materials, reflective paints and surfaces. Also, shading strategies are important and could prove to be, let's say, less costly than greening, especially when it comes to maintenance, plant species, and environmental impacts, which were not really emphasized in this study. The final limitation is that this study was also limited to a specific type of unit, which is just a single home. Future work in this area will include sensitivity analysis for different strategies to further understand their effectiveness, specifically here in Bahrain. Should also look into properties of different building materials and how they react to the climate as well. And finally, a cost analysis should be done in the future in order to understand the costs that come with such strategies, such as maintenance, application, and operational costs, if any. Thank you very much for your attention throughout the presentation. Please let me know if you have any questions.